TikTok University. All right, ready? Look at 23. This is part 2 of the video, by the way. Of the same day, October 13th, redux. Colin, you seen Apocalypse Now, bruh? Ooh, that's a classic. Just check it out. What? Yeah, yep. Okay. So 23 is a very similar question to the ones we've been doing, except there's no numbers. It's all just variables, right? So what would you do if a problem asked you, you've probably done one already, right? Where they give you the mass of a block. They tell you it's sliding to the right with some initial velocity. Okay, let's call that. I don't want this to be this is where it gets a little tricky. Because I don't want to make that look like a force vector, right? It's not, it's a velocity vector. So I'm traveling with some initial velocity v naught, okay? And then we exert a force, F, on the block. Now, would there be two vectors like this that cancel out? Yeah, those cancel out, so sure, put them on there, but we don't really care about them so much. And so this force, okay, is exerted for a time period. How long is the time period in this problem? T, lowercase t. So you got to make sure we're precise with usage of the symbols. Now what it's asking is, what is the final velocity in terms of m, v naught, f, and t? Those four symbols. Okay. So what's the first thing you might do in a question like this? Huh? Find acceleration? Yeah, that's a good idea. That's not what I was going to say, but it works, yeah. Maybe let's put this over here. We know the, over here. Because we know the acceleration is going to be what? Again, we're working with these four symbols. The force divided by the mass, right? Because that is the net force, right? Yes. That's the net force in the block. So the net force divided by the mass would give me the acceleration, F equals ma. Mm-hmm. Everyone cool with that? And then, well, okay, so well, then what would we do with the acceleration? Not this, I don't want to use this one because this is time independent, and I want to involve time in my problem, so that tells me that I don't want to use the time independent. But I could say, what I was going to say originally is, what are we looking for? The final velocity. Don't we have a formula that tells us how the final velocity is equal to the where you started? How fast were you going? Plus your acceleration times your time, right? So that's the key moment in this problem, I guess, is to identify, this gets us there with what Aiden said. So if I can replace that A with F over M, I'll be done, right? So my final velocity is my starting velocity. There's my V naught. I got my V naught in my formula. Plus my acceleration, which is the force divided by the mass, multiplied by the time period. Now let's see, did we do it? Did I find the final velocity in terms of those four symbols? Yes. So we say thumbs up, we did it. You guys okay with that? Okay. 24 is very similar. A block is same thing, a block of mass m is sliding to the right with an initial velocity of v naught. Yeah, actually, no, I changed my mind. You guys should try to figure this one out yourself. You'll learn more that way than, obviously, following along, you'll learn something, but you'll learn more if you can actually do it yourself. So I'll give you a big hint, though. Part A is asking how much time it takes to come to rest. You're probably going to want to use like something like this. You have a starting velocity, the ending velocity. You know that if you're coming to rest, what's the ending velocity? 0. And then so then you can solve for the time. For part B, how far does the block travel as it's coming to rest? Well, you're trying to relate an initial velocity, a final velocity. You can figure out the acceleration in terms of the force and the mass. And then you're solving for this. How far did you go? So I'd recommend using the time independent equation for part B, sorry. So, you guys cool with that? So tomorrow I'm going to go over the stuntman slamming into a cushion questions. You're welcome to, you certainly have the tools right now to solve them if you want to. I would definitely suggest maybe trying one if you have time, but more importantly, get caught up on, these more straightforward ones through 22. How are you guys doing on those overall? I mean, are you finding them like pretty straightforward, not like super confusing?
Yes, sir.
Okay. So yeah, tomorrow I'll go over like the stuntman problems, like for example, 25 or 27 are going to be involving. A lot of them are going to involve the time independent.